Welcome to decimals. So we have our decimal measuring tapes, and I'm just going to show you how to use those with decipipe style representation. If you measure something that is, let's say 15 centimeters, and you flip it around, it will say 0.15 meters, or 1/10 of a meter, and 5/100ths of a meter. Now the students aren't saying the th enough. You know, they're saying tens, hundredths, and it doesn't really sound like the th, which means the parts, 1 out of 10 parts, 1 out of 100 parts. You slap this on the board and you go th, 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 like thong. Doesn't work in other countries because a thong is a undie, but it works here because we call these thongs. So 10th, 100th, and so on. So when we get into the actual making of it, what I will do first is I won't bring out this tape, or I'll bring it out, but they won't be told how to use it, because what I will do is stick a 1 meter pipe or 1 meter bit of wood or 1 meter string, but I like the pipe and wood better because it can't be folded, so it's harder, on the desk in front of each pair, and I'll say, okay, I've got this bunch of straws here, yeah, that type of thing or that type of thing. Can you make me a 10th? What is a 10th? So a 10th, and this is all I write on the board, and this is all I just keep going back to if they ask for more help. A 10th is 1 out of 10 parts. That th means how many parts. It's 1 out of 10 parts. So it's 1 out of 10, or 0 wholes and 1 out of 10 parts of a whole. So that's it. Go make a 10th. And remember, they haven't got the measuring tape on the table. They've got like just a plain white pipe or a plain bit of wood cut to exactly a meter by Bunnings or similar. And so, or a streamer if you're really desperate, a 1 meter length of streamer. And now their challenge is to make tenths and hundredths using these straws, which are not cut to a tenth or a hundredth yet. So once they do that and they end up with these and they can prove how many tenths they need, usually they do realize they have to measure the pipe first, but I don't even tell them that. Then I say, well, can you make a hundredth? A hundredth is 1 out of 100 parts, 1 out of 100, or 1 over 100, but 1 out of 100 is better language, and 0 wholes, 0 tenths, and 1/100th as a decimal. And then eventually they get to that type of scenario where they have their hundredths as accurate as they can, and they have to prove to me that they have 1/100th and how many hundredths make a whole. But I hope that they don't make 100 hundredths, or I say that's going to take too long, guys, the bell's going to go. Can you think of another way to prove it? And usually they reference it to the tenths there. Once they do that, we do the scrolls investigation, which is in the unit plan, which is a really valuable calculator investigation. Then we go on to streamers. So streamers are random lengths then. They're 30 centimeters, 32 centimeters, 68 centimeters, whatever I rip it at. Now I've got this streamer, can you make a 10th of that? Can you make a 100th of that? So that's quite challenging, but I've done that even with extension grade 2s, and they got it. It was just, bit by bit, step by step. It's a great mix of explicit teaching and productive struggle in the one lesson. So then we can use these to race along it or to compare decimals. The classic misconception is, say, that 0.45 versus 0.6. Which one is bigger? And so what do you think the students will say? They'll go for 0.45, won't they? Because it's a longer decimal. So they see it as 45 and they see this as 6 in terms of whole number. But if we use now what we've got here, which is essentially decipipes, we've made our own really, really cheap straw decipipes, essentially, without having to buy expensive ones from across the ditch. And we are making 1/10, 2/10, 3/10, 4/10, because we've got 4 of the tenths, 5 of the hundredths, so 1/100th, 2/100ths, 3/100ths, 4/100ths, 5/100ths. Then we've got that value there as 0.45 or 45/100ths, 45 out of 100 parts of a meter. And we really reference the meter. It's 1 out of 10 parts of a meter. It's 1 out of 100 parts of a meter. And then we've got 6/10ths to make on this side. So 1/10, 2/10, 3/10, 4/10, 5/10, 6, tenths. And so now we can see which one's longer, can't we? We can see that the 6/10 is longer and therefore worth more than the 0.45. And yes, you can just teach them, oh, I just say add a 0, guys, but that's not really showing them why it's longer. Like if you just say to your students on the whiteboard, hey, add a 0 and now it's 60 versus 45, you're just actually enforcing the whole number misconception, as Doug Clark and Anne Roach in particular would say. So adding the 0 at the end isn't a long-term solution or an understanding-based solution. It's just a process-based solution. But showing them in materials that they have created themselves, that's an understanding-focused solution or a conceptual solution. If they are not quite accurate enough in their tenths, we always have these. These are just bundling sticks that come in precisely 10 centimetres. So if their tenths are tripping them up a bit, or you want really, really accurate ones when we race to one hole and we roll the 3-dot dice for the tenths and a 6-sided dice for the hundredths, and we race to one hole along this meter, or 1.5 because it goes to 1.5, which is even better, then you can use these. And then for the hundredths, you can use these as well, that are just sort of decimal square tiles, deci unit chips they're often called online. Or you can just laminate the grid paper that's 1 by 1 centimetre, print it in colour or photocopy it in colour type of thing, and then laminate and get the kids to slice it up for you. And they only need really 10 or 15 of them each to be able to play the game, because then they can keep renaming it as they need. So yeah, that's how we'd use them. I like the straws even better though. Like I use these a lot because they're low maintenance. But after they created their straws, we always bag them, just like when we do fraction walls. Never chuck them out. Always bag them, baggy them. And I'm just having them in a little container. So whenever you're using decimal representations later, you've got them. So we know now that this is 4 out of 10 parts and 5 out of 100 parts of a metre. But this is 6 out of 10 parts and 0 out of 100 parts. But we see that the 6/10 is worth a lot more than the 4/10 and 5/100. We can also link to money. So if I say each straw, tenth, cost me 10 cents worth of straw after you'd cut it, then that is worth 60 cents, or 60 cents as a dollar format, as you'd see it at the canteen. And we might put it there actually, so it sort of matches where it would be on the measuring tape. And then if we link to this one, then this one is going to be 45 cents, and we could even find a 5-cent coin and put it there. Now, I do use real coins for my fish bowls. Obviously, the kids use the fake coins. I'm not that silly. But in the fish bowl, it just looks better. It looks shinier under the classroom lights. They feel real. So if a partner's using them with you, they get to feel it. If I'm really trusting my class, which I should, generally, if I've built that culture up, I can hand one around and just watch it go around the circle. And so the students can feel the coins, because they may not feel many coins these days. So yeah, now we can see it's 45 cents versus 60 cents, or this is 45 cents versus 60 cents. We could also write that as 0.45, sort of like as a dollar format, and 60 cents in dollars format. So 0 whole dollars, 6 of the 10 cents, 0 of the hundredths cents, or 0 of the single cents. And then we could also think about percentage, because we're out of 100 there, 100 parts to a metre. So this is 45% and this is 65%. Nice percentage link. So record as much as you can. This is also 40 out of 100 parts of the metre and 5 out of 100 parts of the metre. And this is 60 out of 100 parts of the metre, or we could write 45 out of 100 parts, obviously. And you could add this as metre too. And then therefore it could be 0.60 if you wanted to later, without using the 0 as a support that is not a good kind of support, is a bad kind of understanding support. And I also like just doing this to show that the 0 at the end doesn't matter, so that they don't think that is worth more than that. They are both worth the same, because they have 4 of the tenths, 5 of the hundredths, and 0 of any other parts, but that doesn't really affect the value when it's a decimal. The 0 at the end doesn't affect decimal value, only whole number place value, when it essentially holds the places for others, or creates a power of 10 pattern for the other place values. So I think that's all the links probably enough links for decimals and enough recording that you'd want to push out of the students bit by bit for that. And yeah, I just find the measuring tape invaluable because we always used to have inches on the side, on the other side of the tape. And, you know, we're Australian, so that doesn't really work or add too much meaning to us. I mean, maybe later on converting units of other countries, I don't even know if that's in the curriculum, but it's definitely not up to year 6, it's not. So it's not really value adding in primary school, whereas just being able to measure something and go, oh, it's 18 centimetres, it's 0.18 metres, is a good early experience for even grade 3s at first, just for front loading. And then, you know, say in grade 6, that's curriculum, but in grade 4, 0.5, 0.25 is curriculum as well now. So yeah, but more importantly than curriculum, this is real life links. It's linking decimals to measurement. It's linking decimals to monetary values. If you had a decimal that had cents that wasn't on the 5 or the 10, I just use these to represent single cents. So these are also my representations for 1 cent coins and my representations for 1 out of 100 parts of a meter. So they double for both since we don't have a 1 cent coin. So get on Amazon or anywhere that sells really cheap bundle packs of paper straws. Have a whole bunch. Head to Bunnings and see if they've got any offcuts that they can donate to the school, or carpentry places nearby, or parents that work in carpentry. If they've got offcuts that they can cut you to precisely a metre, or pipes, if they're a plumbing-based business that can cut exactly a metre. The pipe was my favourite because it sort of looked like the white straws, the pipe we used in class that you see in the photos in the unit, because that was just, it literally looked proportional to a whole, a tenth, a hundredth. And then in crazy times, you can try to make them make thousandths, and they'll just be like, oh, thousandth is so small. What I really loved is at the end, we reflected on what's bigger, a tenth or a hundredth. And we compared that to our ideas at the start. And most people obviously thought a hundredth was going to be bigger because hundreds, that link. But tenth is clearly bigger. You know, if you were asked which one you want the tenths every day of the week over the hundredths. You want the 10 cents over the single cents. So I think that link makes it much less abstract, which is the goal, that we've got concrete manipulatives for decimals. Decimats are great, but they're pretty abstract. I haven't used the decimat much in real life. So I think the most important first representation is money and measurement. And when you can do them together like this, even better.